Hello everyone. Today I am going to explain to you about collision resolution using quadratic probing, hashing in data structures. Hashing is an important concept in data structures that allows fast storage and retrieval of data. However, collisions occur when multiple keys are mapped to the same index in a hash table. To handle this problem efficiently, collision resolution techniques are used. In this video, I will demonstrate how collisions are resolved using quadratic probing, an open addressing technique that reduces clustering and improves hash table performance. What is a hash table? A hash table stores data using a hash function. A hash table is a data structure that stores data in an array format. A hash function is used to convert a key into an index where the value is stored. Here in the given figure, we can see there are three given keys. They are stored using a hash function into the index where the value is stored. What is a collision? Collision occurs when two keys map to the same index. A collision occurs when two different keys generate the same hash value and try to occupy the same index in the hash table. Need for collision resolution. Data loss may occur. Performance decreases. Proper handling is required. If collisions are not handled properly, data can be lost and the efficiency of the hash table decreases. What is quadratic probing? Quadratic probing is an open addressing technique, collision resolution technique. Quadratic probing is an open addressing technique where we search for the next available index using square values instead of linear steps. Here we can see the interval between props is linear, and here the interval between props is quadratic. Quadratic probing formula: h key comma I equal to h key plus I square plus table size. In this formula, I represents the number of atoms. The square of I helps reduce clustering by increasing the probe distance. Let us now understand quadratic probing with an example using a hash table of size 10. Here, three keys are given: 15, 25 and 35. Key 15 is hashed using the function key mod 10, which gives the index 5. So since index 5 is empty, the key is inserted successfully. Key 25 also hashes to index 5. Since index 5 is already occupied, a collision occurs. Using quadratic probing, we calculate 5 plus 1 squared, which gives index 6. Since index 6 was empty, key 25 is inserted there. Key 35 first collides at index 5 and again at index 6. Using 2 squared, we reach index 9, which is empty, so the key is inserted. Advantages and limitations. Advantages are it reduces primary clustering. Its limitations involve secondary clustering is also possible. Hence, we can come to the conclusion that quadratic probing efficiently resolves collisions in hash tables Thus, quadratic probing is an effective collision resolution technique that improves the performance of hash tables.